Hello everyone. Today we are going to discuss the first module of your engineering chemistry. Topic is electrochemistry. So in this chapter, in this module, we are going to discuss the transformation or we will discuss the relationship between the electrical energy and chemical energy. And you see here electrochemistry. So there are two terms. So as the name itself says, the definition of this electrochemistry concept. So here electro, that means electrical energy or electricity, and chemistry means chemical reactions or chemical transformations. You can say chemical reactions. That means electrochemistry is the relationship between electricity and chemical transformations or chemical reactions. So before going to define this electrochemistry, we need to remember the two important statements. That is, certain chemical reactions can create electricity. How? So by spontaneous redox reactions, the movement of electrons from one metal to another metal takes place. That means movement of electrons, in the sense, that is electricity. So by the use of chemical energy, which causes the electricity, means which produces the electricity. That is the first statement. And the second one is, by the use of electrical energy to bring about non-spontaneous chemical transformations. As I told you in the first statement, certain chemical reactions, not all the chemical reactions, means, so how we know that metal which undergoes chemical reactions, means certain metals, if you consider certain metals, you can take zinc and copper. Zinc metal, so which is easily undergoes oxidation, and copper, which is easily undergoes reduction. So that is the main important chemical reactions which brings about electrical energy. And here, so as I told you, from the first and the second statement, the first one is certain chemical reactions can create electricity, and the second one is electricity can make certain chemical reactions happen that would not happen otherwise. That means it requires some external energy, then only the metal undergoes chemical reactions. That is the external energy, in the sense we are using electrical energy or electricity, by the use of electrical energy to bring about a chemical reactions, right? So in this concept, electrochemistry, now we can define this electrochemistry. What is an electrochemistry? Electrochemistry is the branch of chemistry which deals with the study of production of electricity from energy released during spontaneous chemical reactions, and the use of electrical energy to bring about and non-spontaneous chemical transformations. Once again, here, as I told you, electrochemistry is the relationship between the electrical energy and chemical energy. As from the two important statements, that is, electrochemistry is the branch of chemistry which deals with the study of production of electricity from energy released during spontaneous chemical reactions. By the redox reactions, spontaneous redox reactions causes the electricity. And the use of electrical energy to bring about a non-spontaneous chemical transformations. So that is an electrochemistry. And here, so we need to remember some of the important concepts here. So the first one is electrode potential. Electrode potential. As we know that, what is an electrode? Electrode is nothing but a metal, right? Which may be an anode or cathode. So that is a metal. What is an electrolyte? So electrolyte is a substance, so which can conduct the electricity. So either in a molten state or in a solution state. So generally we are taking a solution state substance. So we know that electrode and electrolytic solution, or we can say electrolyte, right? So here the concept of electrode potential. What is an electrode potential? So here electrode potential is the potential difference developed between the electrode and electrolytic solution interface. I mean, here, if you take an electrolytic solution in a beaker, so which contains an electrolytic solution, when you dip the electrode into it, so here it contains an electrolytic solution or electrolyte. So the electrode is dipped into this solution. Some of the potential is developed. The potential is developed between this metal, that is an electrode. This is an electrode, and this is an electrolyte. So electrode potential is the potential difference developed between electrode and electrolytic solution interface. So that is the potential developed between the potential of the interface between the electrode and the electrolytic solution is called as electrode potential, and it is denoted by capital E. So remember here, so the electrode potential, it is denoted by capital E, and electrode potential is the potential difference developed between electrode and electrolytic solution interface. Understanding here? Yes. And the next one is, what is standard electrode potential? Standard electrode potential. What is standard electrode potential? So here the name itself says, means at a standard conditions. So the standard electrode potential is the electrode potential when the electrode is in contact with the solution of unit concentration at 298 Kelvin. At 298 Kelvin is called as standard electrode potential. So standard electrode potential is the electrode potential when the electrode is in contact with the solution, that is electrolytic solution of unit concentration. It may be a 1 molar concentration at 298 Kelvin. That potential is said to be a standard electrode potential. Understanding here? So, as we have used here the metal electrode. If you use the gas electrode, so that if you use the gas electrode, we have to maintain or we have to take 1 atmospheric pressure. So if the gas electrode is at 1 atmospheric pressure, we are measuring the electrode potential. So standard electrode potential, it is denoted as E naught, where the electrode potential it is denoted by capital E and the standard electrode potential is denoted as E naught, capital E naught. Right? And the last one is cell potential. What is a cell potential or EMF of the cell, electromotive force of the cell? That is cell potential. Cell potential or EMF of the cell. What is cell potential or electromotive force of the cell? So here the cell potential is the potential difference between the two electrodes in a galvanic cell. So if you take a galvanic cell, so here if the electrode and these electrodes are connected to a voltmeter, that is externally connected through a wire, and internally these two are connected through by means of salt bridge. So here you take a zinc sulfate solution, ZnSO4 solution, and zinc electrode is used. So here copper electrode is used, and this electrolytic solution is CuSO4 solution. So cell potential is the potential difference between two electrodes in a galvanic cell. That is called as cell potential, and this cell potential is denoted as E cell is equals to E cathode minus E anode. So where E is the electrode potential, but we are measuring the cell potential. Cell means the coupling of two electrodes. So here zinc and copper electrode is coupled. That is an galvanic cell. Right? So E cell is equals to E cathode. Which is cathode here? Copper electrode is the cathode. And zinc electrode is the anode. So the electrode potential, that is E cathode, E copper minus E zinc. That is a cell potential of the galvanic cell or EMF of the galvanic cell. So like this we are going to identify the cell potential or measure the EMF of the cell. I hope you understood the pupils these three concepts. That is, what is an electrode potential, what is standard electrode potential, and what is cell potential or EMF of the cell. Right? Yes. Now we will go through an important derivation, that is Nernst equation, derivation of Nernst equation for a single electrode potential. So when we take a single electrode potential, so how do we derive the Nernst equation? We will discuss now, right?